future is now. In the future is Tesla drive-in movie theaters? Wait, what? No. Anyhow, this is battery day reactions. Okay? But I'm skipping basically to the battery part. Okay? Because that's really the key. I mean, I'm skipping over the investor relations, skipping over the general state of the company. That's all fine and good. Okay? And they should be starting any minute. So they're on break, but as you can see, all the Teslas out there sitting in a nice uniform fashion, all social distancing, of course. So, anyhow, watch the whole thing. Watched it a couple times, actually, just the battery part multiple times, basically to, just to reinforce the data in my head. And here we go. And I like what they did here, okay? If you don't think that all the cars on the road cause this, then you don't understand what's really going on, okay? Heating up the planet is making everything drier and catching fire. Okay, this is just what's happening. We're going to have more and more fires the hotter and hotter the earth gets. That's not even physics or science. That's just basic common sense. Okay? And I see why they did that. They didn't really say why, but this is something that has to be dealt with. Let's see what they say about it. The fact that they have to say this is real is just stupid.
Hello, everyone. Sure. Thanks, Elon. Oh, hi. I'm Drew Baglino, SVP of Powertrain and Energy Engineering at Tesla, and I'm incredibly excited to talk about what we've been doing at batteries here at Tesla.
Great. So let's see. You got the clicker?
Yeah, I've got the clicker. Yeah.
Okay. Let's yes. I'll take it first, perhaps.
Sure.
So obviously the issues we're facing are very serious. With climate change, and we're experiencing these issues on a day-to-day basis. It's incredibly important we accelerate the advent of sustainable energy. Time really matters. This presentation is about accelerating the time to sustainable energy. So the past 5 years were the hottest on record. We have what looks like a wall for CO2 ppm. It's obviously, this time is not like the past. It's really important that we take action. Running this climate experiment is insane. So,
especially when it's just a transitory one anyway.
Yes.
We're going to run out of these fossil fuels. Let's just move to the future and not run this experiment any longer.
Yeah. Talk a bit louder.
You got it.
Okay. So anyway, there is a lot of good news though. A lot of people may not be aware that wind and solar comprise 75% of new electricity capacity in the U.S. this year.
Got to stop it right there. That's super important. At first, when I saw it, I'm like, wait, 76%? I didn't quite understand what was going on there. And what they're saying here in 2010, okay, 10 years ago, 46% of electricity in the U.S. was generated with coal. And the reason being is we have a ton of coal in this country, just like China has a ton of coal in their country. And that's why China uses a lot of coal for energy generation. Now, it's important to get rid of coal. And you say, well, why coal? We need to get rid of oil. Coal is much dirtier of an industry than oil, inherently. Oil's, a dirty industry too. But it's not like solar. It's not like wind energy, So anyway, this is very important. Anyway, let's move forward.
So this is a really major. So the grid is going sustainable very, very quickly. Now, it's also worth noting that the length of time that power plants last is on the order of 25 years. So even if 100% of energy generation was sustainable, it would still take 25 years to convert the grid. And it's also worth noting that in the past 10 years, power production from coal has dropped in half. So it went from 46% of electricity in 2010 to 23% in 2020. So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster.
So yeah, that's definitely key what he's saying. You can see Elon's a little nervous. They're both a little nervous. You know, they've been waiting to do this presentation for a long time. Okay, let's go to the next. Anyway, Tesla's contribution. Obviously, 1 million plus vehicles already. Every vehicle that's produced is basically getting rid of an ICE car. So every Tesla produced is basically one less ICE car. You know, assuming nobody goes back to an ICE car. You know, which most of the cases is correct. I don't know the percentages on that, but it's probably over 95% are going to stick with electric once they go electric. But I mean, that's just me guessing. That's not, I don't have any data on that. Let's see, 5 gigawatts of stationary battery. Now that's going to increase heavily once they get the batteries produced in full. And then you've got, let's see, 26 billion electric miles driven. So every mile driven electric is just not polluting. So, I mean, the more billions and billions of miles, it's like billions of hamburgers served. It's the same concept. I mean, you just need billions and billions more electric miles driven. And 17 terawatt hours of solar generated. That's also low. Both of these are very low on their stationary and solar because they're focused on the vehicles first. Got to get people in these cars first. I mean, this is 2-3 years in, you know, maybe even 5 years before they really start ramping up stationary batteries and solar generation. You know, I think it will be one of the bigger sides of the business in general on the long term. I mean, the energy is a huge, you know, industry. So anyway, I'm going to skip by this because I wanted to go through a few things really quick. And let's figure out where we are.
So in terms of Tesla, expect to make out of there, but this is really pretty small in the grand scheme of things. That's only 0.15 terawatt hours.
This is what investors aren't going to like. So obviously, you guys know this is mainly a stock channel, Tesla channel, future channel. Okay, so when I see the 2 trillion number, that just instantly jumped out at me. You know, the stock price, or the stock was actually going down during the whole, you know, buy the hype, sell the news. Didn't surprise me. You know, we trimmed our position a day and a half ago because I already saw the kind of what direction we were going. So I was just being on the cautious side instead of the greed side. Okay, no need for me to get greedy on anything. I'm just making the best plays I can. But anyway, back to the 2 trillion. Okay, investment in materials, cell and battery manufacturing, 2 trillion. So what do you think this company really has to be doing and cranking in if the investment in all of this for all these factories and everything is going to cost $2 trillion? Okay, and this is a big deal. I mean, the point is this is a massive investment in the company. You know, the company has to continue to invest. I mean, I used to think, okay, Tesla, it's Tesla 2030, Tesla 2030. Now I'm starting to really see, this really woke me up, the battery day, that it's not Tesla 2030, it's Tesla 2040 and 2045, that I think this company is going to be going super strong over the next 20, maybe 30 years. I think they're going to continually have to grow over the next 10 to 20 to 30 years potentially, because they're not going to be complete with their plan. Their plan will not be complete in 10 years. That's just not realistic. Okay, I mean, I know they will have achieved a lot in 10-year span, but this is really a 20-year plus investment. So the people who are really long-term Tesla, you should be really cozy, because now you don't have to worry about cutting your shares in 10 years or whatever it is. I mean, this company is going to continually, you know, be growing, will be a growth story over the next 20, maybe even 30 years. Okay, so that's what I get. I don't look at this and I'm not negative about it. You can see that one gigafactory produces 0.15, and here's what they're gonna get at. Let me see if I can dig it. Anyway, they're trying to basically, you know, get the factories down, meaning turn one factory into the production of 7 factory investments, and that's really what they're trying to do. And you'll see that later on in the
And it costs
video.
too much. So
We would
Oh,
need
I'm sorry.
135 fully
Oh.
built out Nevada gigafactories to achieve
135 gigafactories to get to 22 terawatt hours. 135. That's ridiculous. So obviously they knew this and they had to figure it and said, how are we going to do this? How are we going to, take these factories down? We can't build that many factories. This is ridiculous. It's going to take us 50 years. Okay? I mean, let's think about it. Hey, we might as well. Let's bring the math up. All right. 135. Jesus, 135 factories divided by 30 years. They would have to build 4.5 factories, gigafactories, every single year for the next 30 years. Okay? Investors aren't going to like that in general. I'm telling you that right now. Investors aren't going to like, I mean, granted, I'm not saying they're doing that. They'll explain how they've reduced with how they're reducing that, okay, by 7. So let's assume that they're reducing it by 7 anyway. 135 divided by 7 equals, they're still going to need 20. Okay, now we're definitely there. 20 gigafactories instead of 135, huge, huge difference. Okay, 20 divided by even 20 years, I'm not even going to go 30 years. Oh, let's see, that's 1 factory per year. 1. So they figured this out. They can't build, 4.5 gigafactories every single year for the next 30 years, but they can easily build 1 gigafactory a year for the next 20. Okay, so you'll see how this breaks down.
20 terawatt hours a year. It's not scalable enough of a solution. We need a dramatic rethink of the cell manufacturing system to scale as fast as we can and should.
yeah, and I think we should view this as more than just a question of money. Money is sort of like an ethereal thing, but it's really the amount of effort. You have a certain amount of how efficient that effort is. For a given amount of effort, you want the most amount of batteries. So it's not just a question of like, well, if we had $2 trillion, tomorrow you could make this. It's not that easy. You actually need to organize a massive number of people, build a lot of machines, build the machines that make the machines. And so it's incredibly important to have that effort yield the most number of batteries. So, and then goal 2, obviously, we need to make more affordable cars. I think one of the things that troubles me the most is that we don't yet have a truly.
Got to stop them again. Okay, you can see in this curve that it's flattening out, that they're not getting more and more affordable. Okay, that they actually have to do something to get more affordable. Well, Elon's already ahead of this. What do they have to do to get more affordable? Go more vertical, okay, integration wise, and start mining, start manufacturing, and building your own batteries, obviously. That's what they're doing. They have to do this to supplement all the other batteries from Panasonic, LG, CYTL, Cattle. So it's important. This is the only way to take this curve down. The first time I saw this curve, granted, you'll see it. It's easy for me to say in hindsight, oh yeah, they took the curve down. When I saw this, I'm like, this isn't going down fast enough. It's just not. I'm like, how are they going to bring it down? And they actually show this slide again with the curve coming down. But I was like, oh boy, this is trouble. Let's see if, what he says. I can't remember exactly.
Car. And that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down. We've got to make, and we've got to be better at manufacturing. and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough. So we're given this a lot of thought over many years to say, okay, how can we radically improve the cost per kilowatt hour curve? It's been somewhat flattening out actually in recent years. So
I mean, early growth was promising, but you can see we're kind of plateauing. So that's what's motivating us to rethink how cells are produced and designed.
Yeah, exactly. Yeah, and EV market share is growing, but EVs, aren't still accessible to all.
And why are EV markets growing? Let's take a look. Okay, 2009, 10, 11, nothing, 12, nothing. 13, all of a sudden, 13, you have a couple electric car companies that came in, and of course you have the Model S. And then you could see a little bit of growth there. Same thing with 14 and 15 with the S and X. I guess I can't remember when the X came out exactly. And then 16 it ramps up. 17 it's ramping up. 18 it's ramping up. Now we're getting up to, what is it? The EV market share. It's right around 1.8%. Okay, which is obviously still nothing. So gold 2 problem, EV market share is growing, but EVs still aren't accessible to all, and mainly because of the price. I mean, if a Model 3 was $20,000, oh my God, there would be like a 2-year wait list for the car. You know, think about it that way. You would be waiting forever for a car from Tesla if it was extremely cheap in the first place. I mean, you would never be able to get a car. It would take years. There would be such a backlog for orders if they were cheaper, you know. So anyway, that's the that's a good chart. I mean, that definitely lays out where we're going. Okay, and if you take ICE cars, they're going to be gradually declining, and they will crash. They will come off the ceiling and be done for.
So as Drew was saying, it's like starting to flatten out a little bit because the rate of improvement of the affordability of cars is just not fast enough. So that's why we got Battery Day.
Yeah. To make the best cars in the world, we design vehicles and factories from the ground up. Next.
Yeah.
And now we do this for batteries as well.
Okay, so we know they're doing the batteries. Oh, okay. So now we're going into the basic battery structure. Okay, they're basically giving you a chemistry lesson. You know, I mean, this is some basic stuff, but I don't think most people don't understand how a battery works anyway. So they're kind of trying to explain it, and I'm not sure I'm going to go into the specifics on that. Rather than, I want to get into where their cost reductions really lie. But anyway, we'll continue.
Yeah. It's weird, the slides don't show up quite right.
Here's the mistake. Right here. Here is the mistake. All these cars are honking. What the hell's wrong with Elon? How come these cars aren't clapping? I mean, couldn't he have set that up? I mean, really? The car's horns can make any noise he wants them to make, right? So, I mean, they should have, once again, maybe they should develop a marketing actual platform or an advertising platform. So they can actually, I mean, this would have been classic. My wife was like, why aren't all the cars clapping? I was like, oh my God. I'm like, that would have been hysterical. But it would have been like great. You know, it would have showed what you can do again. And it's like, obviously, they're putting this together during the middle of this whole crisis that we're in globally. I mean, otherwise, this wouldn't even be displayed like this at all. But, oh, by the way, yeah, there's that red car on the left. Well, there's the Cybertruck. There's my wife's car on the far left. You can see it peeking out there. And you can see probably one of my future cars, which would be the Roadster on the left. Obviously, I'm never going to own the semi-truck. So anyway, I just thought that was kind of, they might as well have done that. Come on.
What shows up on the screen is not quite what shows up there.
Oh, okay.
It's different.
Yeah, I think it's because that's
Kind of goofy, but whatever. I'm not
so
as goofy
let's
as
get
these
started.
clowns. Come on.
We have a plan to halve the cost per kilowatt hour.
Yeah.
And it's not a plan that rests on a single innovation, some research project that'll never see the light of day. It's a plan that has taken creative engineering and industrialization across every facet of what makes a cell into a battery pack, from raw material to the finished thing. And we're going to go through that plan with you today, step by step, and build up how we get to these goals and how we accelerate this transition and make our vehicles and our grid batteries more affordable.
Yeah.
Okay, this is the actual presentation. These 5 dimensions of what they're doing with batteries, this is everything.
Innovations, and then when you add them up, you get a total improvement in energy density and cost. But these numbers are what refer to just this thing.
Yeah, and I want to stress, this is not just a concept or a rendering. We're starting to ramp up manufacturing of these cells at our pilot 10 gigawatt hour production facility just around the corner.
Yeah. So, yeah. It's a video of some of what's going on in the plant. Now, I mean, to be clear, it will take about a year to reach the 10 gigawatt hour capacity. So this is important to appreciate. Like when you build a factory, there's a certain capacity that you design to, and then it takes some period of time to actually achieve that capacity. So I would say it's probably about a year before we get to the 10 gigawatt hour annualized rate with the pilot plant. And this is just a pilot plant. The actual production plants will be more on the order of maybe 200 gigawatt hours, maybe more over time.
And thank you. But let's stack up everything we just saw at the cell level. So just the cell form factor change enables a 14% dollar per kilowatt hour reduction, just that cell form factor change. And now that you've been teased on this factory, we're going to go on and walk step by step through that factory and discuss a series of innovations there. When thinking about the ideal cell factory, we have inspirations behind us in the paper and bottling industry, where from humble beginnings, over a century of innovation has enabled mass scale, continuous motion, unbelievably low manufacturing cost. And when we think about the lithium-ion industry, which is really only in its 3rd decade of high-volume production, it has so far to go to achieve similar scale and simplicity. And that was the inspiration that we set out to the team as we thought about how to marry cell design and manufacturing in the best possible factory. And let's talk a little bit about what's in a cell factory. First, there's an electrode process where the active materials are coated into films onto foils. Then those coated foils are wound in the winding process we just talked about, where if you do have tabs, you have to start and stop a lot. Then the jelly roll is assembled into the can, sealed, filled with electrolyte, and then sent to formation, where the cell is charged for the first time, and where the sort of the electrochemistry is set and the quality of the cell is verified. And we set out at every step of this process to try to take that inspiration we just showed and think about how we make those processes fundamentally better and more scalable. And one of the most important processes is where it all begins, the wet process of the electrode coating. And just to give you all a sense of scale, I'm going to walk through what's in that wet process. You've got mixing, where the powders are mixed with either a water or a solvents for the cathode. That mix then goes into a large coat and dry oven, where the slurry is coated onto the foil, huge ovens, tens of meters long, dried, and that solvent then has to be recovered. You can see the solvent recovery system. And then finally, the coated foil is compressed to the final density. And
so this is where Maxwell Technologies came in, and the reason they bought the company. Okay, their dry battery process. Okay, and basically they can get rid of these huge plants. They don't need all of this if they get rid of that. Okay, not to mention there's the chemical benefits to it. It's not, as unhealthy or whatever. So, but anyway, let's see how he explains it.
You're looking at this, you're like, wow, that's a lot of equipment for one step, especially when you consider that little speck next to the coating oven is a person. This is serious iron involved in making batteries. Wouldn't it be great if we could skip that solvent step, which is one of those dig a ditch and then fill it kind of things where you put the solvent in and then take it out and recycle it, and just go straight to dry mix to coat? And that's what the dry process really is about. And in the most basic form, you can see it here on a bench top. Literally powder into film. As simple as that.
I mean, it's hard, actually, just to be clear. So, you know, if this was easy, everyone would do it. So it's not like dry coating electrode is actually easy. It's actually very hard to do what appears to be a simple thing. And it's worth noting, like, you know, we did acquire Maxwell as like a little over a year ago, I guess.
Maxwell.
And, you know, it's certainly a good company and everything, but the dry coating they had was like, is like sort of, I would call proof of concept. Since the acquisition, we've actually revved the machine that does dry coating 4 times. So we're in revision 4 post acquisition of the machine, and there's still a lot of work to do.
So 4 iterations on this process. Like, you know, he was saying, you know, that, oh, this is simple, this is super easy, and Elon immediately cut him off and said, this isn't easy. They're already on their fourth process of this, and I think they have a ways to go. So this isn't like totally locked down. I think this is where they're kind of hung up here a little bit. They don't really talk about it, but I think, and he's kind of, you know, leading out to, this is not as simple as it may seem, but it's important.
This is like completely in the bag. It's still a lot of work to do, and you know, as you go from like benchtop to lab to pilot to volume production, there are actually major issues that you encounter at every level. It's not like, you know, you make something work on your bench and bingo, now you can make a bazillion of it.
Absolutely.
It's insanely difficult to scale up.
But if you do scale it up,
yeah,
what you saw before.
Wait, what?
Becomes.
Wait, but if you do scale it up, are you saying if? Okay, that's I don't like the word if there. That's a little telling against psychology. But if you scale it up, what do you mean if you scale it up? You mean we are going to scale it up? I mean, and this is where I'm a little sketchy on it. I think I read a little bit. I'm not thinking I'm reading between the lines. I'm thinking this isn't total lockdown. This is not total lockdown yet.
Yes.
Yeah.
So you can see the motivation. A 10 times reduction in footprint, a 10 times reduction in energy, and a massive reduction in investment. But as Elon was saying, simple is hard.
Yeah. Yeah, I mean, to be clear, I would like to not say that right now it's just totally working. It's close to working, but it's not, even now at the pilot plant level, it is close to working. Well, it's fair to say it does work, but with not a high yield.
Yeah.
Yeah. Okay. Now, did that make sense? He's fumbling a little bit there because he didn't want to say it so negatively, but it's not ready. Okay. It's not ready is what he's saying, but it's not fully ready is what he's saying. I mean, it can work, but the yield is so low. So it's not working the way that it needs to get that reduction. Okay.
So we're still ironing out the kinks, but we've made tens of thousands of cells, thousands of kilometers of electrode. I mean, we are on the 4th generation of the equipment, so we've learned a lot along the way. Yeah. I mean, it is super demanding because every atom has its place if you want to deliver the energy density and the cycle life and the supercharging.
Yeah.
But we're confident that we will get there, but it will be a lot of work along the way.
There's a clear path to success, but a ton of work between here and there.
Yeah.
So, but this is a really profound improvement.
Translation: the Cybertruck may not be produced in time. They're planning on putting these cells in the Cybertruck for multiple reasons, and I'll get into that a little bit later, that they didn't actually mention, but I'm positive. But anyway, that's, you know, getting off topic. It's more the fact that, you know, this could stall the production of the Cybertruck. We have the Cybertruck on order, so obviously I want the Cybertruck produced as quickly as possible, but definitely with these new cells.
For people that know battery manufacturing, this is gigantic. we'll probably be on machine revision 6 or 7 by the time we do large scale production. The rate at which the machines are being improved is extremely rapid. Like literally every 3 or 4 months is a new rev.
Ah, there you go. There's a little math for you. Every 3 or 4 months, and he said by 6, they're at 4. So take 2. Let's go to the high end. That would be 8 months out. So 8 months out is in the timeline of the Cybertruck.
And beyond the electrode, we continue to innovate on every other process step. So let's talk a little bit about assembly, which is next. The key to a high-performing assembly line is accomplishing processes while in motion, continuous motion, and thinking of the line as a highway, max velocity down the highway, no start and stop, no city driving.
Exactly, no stoplights and traffic lights or anything. You want the highway.
I want the highway.
Yeah.
And together with our internal design team that makes this equipment and designs this equipment, we coupled thinking about how to make the best cell with thinking about how to make the best equipment so that we could accomplish the fastest parts per minute rates on all of these tools. And through all of that development, we were able to get to the point where we can implement assembly lines, one line, 20 gigawatt hours, 7 times increase in output per line.
That's what I was talking about earlier. 7 times the line output. And this is where the gigafactory, 135 gigafactories divided by 7 when it comes to the battery factories, that gets you down to those 20, around 20 factories. Okay? That is the key. And this is big again, because this enables this company, Tesla, to do things that other companies are not going to be able to do. They don't have these technologies. They're not doing this. They're just buying batteries from battery manufacturers. So, I mean, they'll never be able to scale. Even if you can put a car together with the frame and everything, you're not going to be able to scale. These companies are not going to be able to scale the batteries like Tesla will. I don't think people really understand that. This is super significant. This is, to me, probably one of the most important factors here. Okay, obviously we can't make 135, factories, gigafactories. So that doesn't make sense. So what happens? These guys, meaning Tesla, are going to be producing their own batteries and own battery factories, and the other companies are not going to do this. They are going to buy the batteries. Well, who are they going to buy the batteries from? I wonder. No brainer, man. There's just another way that Tesla can generate tons of money. Just sell a ton of these batteries at a markup to all these other car producers. Now, let me think for a minute. Even if they mark it up, let's say 50% or 30% or whatever for the markup on the actual batteries, that means that the other car companies cannot produce the same type of car for the same price. So even the other car companies are going to be still more expensive than Tesla when it comes to the actual cars, I think. So, I mean, if you figure they're going to be outsourcing their batteries, unless they're making their own battery plants, which, in their own battery technologies, I guess we'll find out. But I mean, I haven't seen anything on my radar at all about that.
Thinking about scalability and pure effort, having one line be 7x the capability is just effort multiplying.
Yeah. So yeah, you can sort of think about like the sort of the fundamental physics of a factory or something. Like I think it's actually quite a lot like the rocket equation, where you've got basically in the rocket equation you've got your exhaust velocity and then the log of the start to end masses. So it's basically saying, how fast are things going and what percentage of the factory volume is doing useful work. And conveyance does not count as useful work. So
only the value-added steps.
Yeah, if you break the factory down into cubic meter sections, and say, or smaller, it could be like 1 liter sections, and say, is a majority of this volume doing useful work? You would be astounded at how bad most factories are. They're like maybe 2 or 3%, including our factory in Fremont. So I think it's possible to get to at least 10 times that volumetric efficiency. So more like 30% ish, maybe more, and be 10x better, which means the factory can be 10 times smaller. And then the other thing is how fast are things going through the factory? It's like speed and density. The faster you go, like if a factory that's moving at say twice the speed of another factory is equivalent to two factories basically, and the company that will be successful is the company that with one factory can accomplish what other companies take 2 or 3 or 4 factories to do. So this is what we're trying to do here is say, okay, how do we with one factory achieve what maybe 5 or even 10 factories would normally be required to achieve?
And this is why, in my opinion, most of the other auto manufacturers will probably not survive. And it's not because they can't produce a car, it's because they're not going to be able to financially produce an electric car profitably because they don't have that integration, and they're not trying to integrate as far as I'm aware of. And I think that's the biggest hurdle for them. They all honestly have to almost, Tesla has to put them on their back and basically, sell them batteries for super cheap to even give them a chance to produce cars down the road. Equivalent cars, for the price.
And the vertical integration with the machine design teams at Groman and Hybar and others allows us to really.
Yeah, don't forget they bought Groman and Hybar. Hybar actually is the manufacturing side of the battery. Groman as well. So these are the manufacturing side. They buy Maxwell, Groman, Hybar. Are the other companies out there buying a bunch of other battery companies and getting integrated? I think it's going to be too late because I think Tesla's going to snatch up anything of any value.
Accomplish that because we don't have all these edge conditions between one piece of equipment and another. We can design the entire machine to be one machine and remove all of these unnecessary steps.
Yeah, basically Tesla is aiming to be the best at manufacturing of any company on earth.
There it is. There it is. That's the line right there. Tesla is going to be the best manufacturing company on earth. Do you believe? The question is, if you believe, let's say in the stock or, plus or minus on the stock or whatever, if you believe that, what he's just saying, if they do this and they become the best manufacturing company on earth, what do you think the value of that company will be? 1 trillion, 2 trillion, 5 trillion? What's the value of the best and the biggest manufacturing company on earth? Doesn't matter what they're manufacturing. They can end up manufacturing anything, trucks, boats, planes, whatever. It doesn't really matter. The point is, when you learn the manufacturing side, like he said, that's the hard part, not making a prototype. Anybody can put a render up or a prototype, say, yeah, this car is going to have this and that or whatever. But when it comes out for the real vehicle that comes out, most of the time the prototypes do not match the actual vehicle. Tesla's not like that, though.
Thing that's actually most important in the long run. I think, just from a company standpoint and from basically achieving sustainability as fast as possible. But I think also for long-term competitiveness, eventually every car company will have long-range electric cars. Eventually every company will have autonomy. I think, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing.
Booyah. That's what he's saying. They're going to dominate the manufacturing. So it doesn't matter that the other companies produce all these cars. They're not going to make a ton of profit. These other companies are not going to make as much money profitability-wise because they're not going to be so refined on the manufacturing side, which is where all the costs lie.
Manufacturing is hard, and hard problems are fun to solve. Okay, now let's talk about formation. In a typical cell factory, formation represents 25% of the investment. And what is formation? It's charging and discharging cells and verifying the quality of the cell. Turns out we've charged and discharged billions and billions of cells in our vehicles, so we know a thing or two about that. The typical formation setup is you charge and discharge each cell individually. In our car, we charge thousands of cells at once. And we took our principal and our power electronics, leveraging Powerwall, vehicle battery management systems, and others to dramatically improve the formation equipment cost effectiveness and density. 86% reduction in formation
Huge.
investment, 75% reduction in footprint.
So
Enormous decrease.
You want to take this one?
Sure. So essentially, what this translates to, based on what we know today, is about a 75% reduction in the investment per kilowatt hour or gigawatt hour. It's just basically 4 times better than the current state of the art to the best of our knowledge. And I think there's probably room to improve even beyond that.
Definitely.
Definitely, yeah. So we're able to, from a volume standpoint, actually get what in a smaller form factor than Giga Nevada, we were able to get many times the cell output. So you can see, like, basically we can get a terawatt hour in less space than it took to make a gigawatt hour. 150 gigawatt hours. So this is pretty profound. It's like I would actually not have thought this was possible several years ago.
Exactly, right there. That's telling. Again, I studied psychology and I love psychology, and so what he said there is profound in itself. Meaning, a couple of years ago, he didn't think this was possible. This is why this is what, when he says, "Oh, this blows my mind," because 2 years ago he didn't think this was even possible. Being able to, he just thought it was going to take these just ridiculous amount of gigafactories. He didn't realize that they would be able to do this.
That we could actually get to terawatt hour scale in less space than what we currently envision for doing 150 gigawatt hours.
Yes, simpler accelerates terawatt hour scale, and that's what we need to do to accelerate our mission. And as Elon said, we're going to try to even improve on this as we push towards our goals, which are.
Yeah. So this is just for. This is just talking about Tesla internal cell production.
The plan, I love it.
Earlier, we will continue to use our cell suppliers, Panasonic and LG and CATL, and so this is 100 gigawatt hours supplemental to what we buy from suppliers, yeah, essentially this does like reduce our weighted average cost of a cell because it allows us to make a lot more cars and a lot more stationary storage, and
a lot more cars. Okay, that's a given, but a lot more stationary storage. That's the big thing. Okay, if you're thinking as an investor, okay, in the company, this is what I think of. Okay, the stationary storage, that's big, and I'm talking mega packs. The mega packs all over the globe that they could be pumping out in all these countries that need this power storage. So if they have hurricanes or storms or whatever, they have this power battery backup. Okay, and this is huge, and they can start actually devoting batteries to that segment. Okay, I guarantee there's countries that want these mega packs. The Australia one is like a pilot plan again. That's just like a, hey, let's try it out and let's see what happens. And then Australia and pretty much everyone realized, holy cow, this is awesome. We need to have these everywhere. And Tesla's like, we can't do it right now. That's too many batteries. We don't have the batteries to do that. Okay, so we've got to put them in our cars now. So we're making all these cars. We cannot do that. So this is huge for the company again when it comes to the stationary storage. He always kind of underplays that a little bit though.
And then long term, we're expecting to make on the order of 3,000 gigawatt hours or 3 terawatt hours per year. I think I think we've got a good chance of achieving this actually before 2030, but I'm highly confident that we could do it by 2030.
Translation, 2032. Okay, Elon time.
Look at the size of that factory on the previous page. It really shows how enabling all of these advancements are in achieving a 3 terawatt hour goal by 2030. And not only is all of that manufacturing innovation fantastic for enabling scale, it's also an additional 18% reduction in dollar per kilowatt hour at the battery pack level.
Big
But wait,
savings.
there's more.
But wait, there's more.
Yeah.
So we have a manufacturing system. We've got a cell design. What are the active materials we're going to put in that cell design? Let's talk about the anode first.
Okay,
Let's talk about
not,
silicon.
because this
Why
video
is
is
silicon
already going to drag like crazy. Okay, I will leave this to the battery experts again. Okay, and we will get back to this. Obviously, silicon. Okay, once again, it's what are the most common elements. Okay, and they're trying to use the most common things. But anyway, hang on a minute. I want to skip by that because there's something I do want to get to. It's more important. Okay, I guess we can get to the cobalt, nickel, iron.
It is a very stable bookshelf, and the challenge with going to pure nickel is stabilizing that bookshelf with only nickel, and that's what we've been working on with our high nickel cathode development, which has 0 cobalt in it. Leveraging novel coatings and dopants, we can get a 15% reduction in cathode dollar per kilowatt hour.
Yeah, big deal.
But it's not just about nickel. You want?
Yeah, sure.
So this is good too. Okay, now here's the thing. I mean, and I think they didn't think this in the past, but the batteries have to be different. Okay, there's not going to be one battery. Okay, there's just not. There's going to be multiple types of battery depending on what you're using it for. Okay, so and they're showing on the left side the iron-based long cycle life. You know, with the small car, the compact car, and the mega packs, right? Okay, that's fine. And then you need a longer range, okay, with nickel manganese. So that makes sense, right? For the Model S and some of the 3s and Ys, and the power walls, okay? And then you have the high nickel content, which is for the trucks, okay? And this is why they haven't produced the trucks yet. It's because the high nickel, content approach on this. I'm pretty sure that's why it's taken a while just for these to come out. The cars are fine and the stationary storage is fine, but the trucks are more complicated when it comes to that. Okay, so they just demand more power.
So in order to scale, we really need to make sure that we're not constrained by total nickel availability. I actually spoke with the CEOs of the biggest mining companies in the world and said, please make more nickel. It's very important. And so I think they are going to make more nickel. But
I wonder how he incentivized. When he says he talked to him, it says make more nickel. Okay, I mean, is that the conversation really? I mean, that could be an Elon conversation. Hey, do me a favor, make some more nickel over there. But for real, I mean, I'm sure that they said, hey, we are, going to need this. In the past, they probably thought, oh yeah, Tesla, yeah, they're not going to need it. Why am I going to start mining and spending all this CapEx on my mining side when you're not doing anything? Now I think they can realize that Tesla's for real now, and then maybe they'll start moving and spending their own CapEx, realizing, oh my God, there's a big opportunity here. And if we have a deal with Tesla, we have a lot of leverage here. The nickel miners have a ton of leverage over Tesla right now. So, I mean, this is to me their opportunity to strike. Even my wife was like, we need to be investing in the actual materials company. We need to be investing in the lithium or nickel or silicon, whatever. We need to invest in those mining companies. So, and I haven't done my research yet on that, but believe it, I'm going to, because some of the biggest companies in the world might end up being the battery mining companies. So that's like my little sneak peek to what other companies that I might be looking into deeply. Okay, who is dominating that industry? And maybe I should be investing in those companies because maybe they're going to be cranking out tons and tons of supply for all of these batteries for all of these companies. So that may be my next major research, and I'll definitely post videos on that once I do my due diligence research before I invest in nickel in some random nickel company. Okay, that sounds funny. Anyway,
There's also, I think we need to have a kind of a three-tiered approach to batteries. So starting with iron, that's kind of like a medium range, and then nickel manganese as sort of a medium plus, intermediate, and then a high nickel for long range applications like Cybertruck and the semi. And something like a semi truck, it's extremely important to have high energy density in order to get long range. So just to give sort of iron a bit more time, like although if you look at the watt-hours per kilogram at the cathode level of iron, it looks like nickel's twice as good. But when you fully considered at the pack level, everything else taken into account, nickel is about maybe 50 or 60% better than iron. So iron is a little better than it would seem when you look at it at the pack level fully considered. It's not as good as nickel. Nickel is like 50 to 60% better, but it's actually pretty good. And so, good for stationary storage and for medium range applications where energy density is not paramount. And
there's massive amount of iron resources. Okay, it's like silicon, iron, lithium. There's just a ton of it on Earth. Okay, so he's clarified that, and I've done my research there. There's a ton of it. Okay, these are basic elements.
Like I said, for intermediate, it's kind of a nickel manganese. And it's relatively straightforward to do a cathode that's 2/3 nickel, 1/3 manganese, which would then allow us to make 50% more cell volume with the same amount of nickel.
And with very little energy trade-off. I mean, just enough to have you still want to use 100% nickel for something like a semi-truck, but really not much of a sacrifice.
Yeah.
And beyond the metals, because a lot of people spend time talking about the metals, actually the cathode process itself is a big target. 35% of the cathode dollar per kilowatt hour is just in transferring it into its final form. And so we see that as a big target, and we decided to take that on. Here's a view of the traditional cathode process. Effectively, if you start at the left and you have the metal from the mine, the first thing that happens is the metal from the mine is changed into an intermediate thing called a metal sulfate, because that's just happened to be what chemists wanted a long time ago. And then when you're making the cathode, you have to take this intermediate thing called metal sulfate, add chemicals, add a whole bunch of water, a whole bunch of stuff happens in the middle, and at the end, you get that little bit of cathode and a whole bunch of wastewater and byproducts.
Yeah, it's insanely complicated. If you look at the total, like if you're just like, it's a small world journey of I am a nickel atom, what happens to me? And it's crazy. Like you're going around the world 3 times. There's like the moral equivalent of like digging the ditch, filling the ditch, and digging the ditch again. It's total madness, basically. And these things just grew up as they're just kind of like legacy things that it's like how it was done before. And then they connected the dots, but really didn't think of the whole thing from like a first principle standpoint, saying how do we get from the nickel ore in the ground to the finished nickel product for a battery. And so we've looked at the entire value chain and said, how can we make this as simple as possible?
And that's what we're proposing here with our process. As you can see,
a little bit different, right?
a whole lot less is going on here. We get rid of the intermediate, metal, water, final product cathode, recirculate the water, no wastewater at all. And when you summarize all of that, it's a 66% reduction in CapEx investment, a 76% reduction in process cost, and 0 wastewater. Much more scalable solution.
Something we got to talk about before the honking starts again is the CapEx investment. Okay, remember, they're barely profitable now, but a big part of that is all this CapEx investments. When they keep reducing all these CapEx investments, their profitability of the company should absolutely grow. Okay, so there could be some surprises in the next couple of years when it comes to their profitability. They could go from pretty flat to all of a sudden kind of cranking profitability. So you're going to see some inflection point there where the profitability will go up like triple within like 1 quarter, and people will be like, "What happened? What happened?" Well, this is what's going to cause it to happen. I don't know when that goes into effect. If I did, I would be betting heavy during that time frame. But I really don't know. I don't know if it's going to be a couple years from now or not. The cars
And then when you
know.
think,
The cars definitely understand. Okay, they definitely understand too. These guys are battery people, battery experts. You know, a lot of YouTubers and stuff, and they're constantly studying this.
but the fact that now we're actually just directly consuming the raw metal nickel powder, it dramatically simplifies the metal refining part of the whole process. So we can eliminate billions in battery grade nickel intermediate production. It's not needed at all.
Yeah.
And we can also use that same process we showed on the previous page to directly consume the metal powder coming out of recycled electric vehicle and grid storage batteries. So this process enables both simpler mining and simpler recycling. And now that we have this process, obviously we're going to go and start building our own cathode facility in North America and leveraging all of the North American resources that exist for nickel and lithium. And just doing that, just localizing our cathode supply chain and production, we can reduce miles traveled by all the materials that end up in the cathode by 80%, which is huge for cost.
Yeah.
Okay, once again, this is a good move by having the factory. I'm a little confused about where they're putting this. They just kind of throw it up on the map because obviously they don't know where they're building this plant. So it's another plant that they're going to be building. I don't think it's going to be anything connected to the Texas plant. I don't think so. Anyway, this is a little confusing to me. I'm confused. Like they're getting lithium and nickel from the Caribbean and from the East Coast and from Canada. I mean, and from Nevada. Okay, I'm a little lost on this. So do me a favor and comment on the video on this. I mean, if you understand this, so this is where I'm a little lost about. I mean, I get it. They're trying to get the materials closer, but so you're not trucking materials all over the place. But I'm still a little lost on this.
To be clear, cathode production would be part of the Tesla cell production plant. So it would just be, basically, raw materials coming from the mine, and from raw materials in the mine, out comes a battery.
And on that note, the way the lithium ends up in the cell is through the cathode. So then we should obviously on-site lithium conversion as well, which is what we will do using a new process that we're going to pioneer. That's a sulfate-free process again, skip the intermediate. 33% reduction in lithium cost, 100% electric facility co-located with the cathode plant.
Yeah. So it's important to note that there is a massive amount of lithium on Earth.
Yeah.
So lithium is not like oil. There's a massive amount of it pretty much everywhere. In fact, there's enough lithium in the United States to convert the entire United States fleet to electric. Like all the cars in the United States, there's like 300 million or something like that. Every vehicle in the United States can be converted to electric using only lithium that is available in the United States.
Discovered today.
What we already know is exists.
People really haven't even been looking.
Yeah, people haven't been trying because it's just like widely available. So, but it is important to say, like, okay, what is the smartest way to take the ore and extract the lithium and do so in an environmentally friendly way? And we actually discovered again, looking at a sort of first principles physics standpoint, instead of just the way it's always been done, is we found that we can actually use table salt, sodium chloride, to basically extract the lithium from the ore. This is, nobody's done this before, to the best of my knowledge. Nobody's done this, and it's a sort of, all the elements are reusable. It's a very sustainable way of obtaining lithium, and we actually we actually got rights to a lithium clay deposit in Nevada.
Over 10,000 acres.
Over 10,000 acres. And then the nature of the mining is...
I guess Elon doesn't lie. Now, he said, hey, we may be getting into the mining industry. He said this like a year ago. You know, I mean, maybe less. I don't know. He said it a year ago, maybe a year and a half. I don't remember. But and now they're getting into the mining industry. They have to. They have to. It's more further vertical integration. It's just saving more money. It's just saving more money. Just another way.
I think also very environmentally sensitive in that we sort of take a chunk of dirt out of the ground, or remove the lithium, and then put the chunk of dirt back where it was. So it will look pretty much the same as before, and it will not look like terrible. And
yes,
it'll
it's
be nice.
not going to look like a pit mine. You know, if you've seen the pictures of a pit mine, I think I have one somewhere, but yeah, it's not going to look completely destroyed.
Nice.
Yeah.
So
simply mix clay with salt, put it in water, salt comes out with the lithium, done.
Yeah, it's pretty crazy.
Yeah. So we're really excited about this, and there really is enough lithium in Nevada alone to electrify the entire U.S. fleet.
Yeah, that's true. Actually, just what's in Nevada, that's basically so much damn lithium on Earth. It's crazy.
So that totally answered my question, because that was one of the first videos that I did on Tesla, and that was literally like a year ago. One of the first videos I did, I was like, well, how much lithium is on Earth? I mean, what's going on? I mean, or whatever, because I thought that mainly a battery was made with lithium in the first place. And, but anyway, I know it's not a big factor, but it's a necessary factor. And they're answering that 100% right now, meaning there's an infinite amount. We don't have to worry about lithium.
The most common elements on the planet.
Yeah, 3.
And eventually,
on the periodic
as
table.
we said at the beginning, when we get to this steady state 20 terawatt hours per year of production, we will transfer the entire non-renewable fleet of both power plants, home heating and battery and industry heating and vehicles to.
Now, I think this chart is totally going to confuse people. Okay, and I really had to kind of think about it, but here's the deal. Okay, Tesla cars are not really being recycled battery wise. Sorry, their batteries aren't being recycled now. And the answer is why? Why aren't they? Because they're not coming back yet. These cars are all brand new. So it's going to take 7, 10, 12 years sometimes to get batteries back from these Tesla cars that are now off the road, and then recycle them. So when Tesla gets those cars back for recycling purposes, 20% of the nickel is coming back, 2.7% of the lithium, and 2% of the cobalt are coming back. Okay? So, and that is huge. I mean, because that, put it this way, batteries of the future that are recycled are going to be cheaper, meaning cars in the future will be cheaper just due to recycling the actual batteries. Okay, my wife's brother actually asked me about this the other day, and he was talking about Tato. He was asking me about recycled, you know, what's about the recycling about the deal, and what's going on with that, and what are they going to do? Well, this is what they're going to do. I mean, they're going to actually benefit from the recycling process, you know, and get a lot of the materials back. You know, and that is big, not just for recycling's sake for the earth, recycling for cost reduction of the future batteries. This is what this translates. I mean, as far as I'm aware of. I could be wrong, but, you know, comment if you think so.
Electric. And at that point, we have an awesome resource in those batteries to recycle to make new batteries. So we don't need to do any more mining at that point. And you can see why. Yeah. The difference in the value of the material coming back from the vehicle versus the ground, you'd always go to the vehicle. And we recycle 100% of our vehicle batteries today. And actually, we are starting our pilot full-scale recycling production at Gigafactory Reno next quarter to continue to develop this process as our recycling returns grow.
Yeah, I mean, to date it's been done by third parties, but we think we can recycle the batteries more effectively, especially since you know, we know our batteries, we're making the same battery as the thing we're recycling. So whereas like third-party recyclers have to consider batteries of all kinds.
Yeah. And just to think about what this actually means, the recycling resource is always 10 or greater years delayed because batteries last a really long time. but eventually it is the way that all resources will be made available, and that's why we're investing in this recycling facility in Nevada.
Yeah. Long term, new batteries will come from old batteries once the fleet reaches steady state.
Right. Okay, so we just talked about scaling cathode and recycling. All of the benefits that you just saw are added to this benefit of a 12% reduction in dollars per kilowatt hour at the battery pack level. Almost at our halve the cost goal, but there's one more section. Take it away, Elon.
So there's an architecture that we've been wanting to do at Tesla for a long time, and we finally figured it out. And I think it's the way that all electric cars in the future will ultimately be made. It's the right way to do things. So it starts with having a single piece casting, or a single piece casting for the front body and the rear body. And in order to do this, we commissioned the largest casting machine that has ever been made, and it's currently working just over the road at our Fremont plant. We have the it's pretty sweet. Making the currently making the entire rear section of the car as a single piece, high pressure die cast aluminum. And in order to do this, we actually had to develop our own alloy because we wanted a high strength casting alloy that did not require coatings or heat treatment. This is a big deal for castings, especially with a large casting. If you heat treat it afterwards, it tends to deform. It kind of like does this like potato chip thing. So it's very hard to keep a large casting to have its shape. So in order to achieve this, there was no alloy that existed that could do this. So we developed our own alloy, a special alloy of aluminum that has high strength without heat treat and is very castable. So that's a great achievement of our materials team. In fact, in general, we've got a lot of advanced materials coming for Tesla, that new alloys and materials that have never existed before. So
they're on the cutting edge. That's the translation. They're on the cutting edge of using advanced materials, instead of just using what people use because they used it for so long. They're changing. They're breaking the mold and the casting, literally.
You're basically making the front and rear of the car as a single piece, and then that then interfaces to what we call the structural battery, where the battery for the first time will have dual use. The battery will both have the use as an energy device and as structure. This is absolutely the way things are done. In the early days of aircraft, they would carry the fuel tanks as cargo. So the fuel tanks actually were quite difficult to carry. They were like basically worse than cargo. You had to kind of bolt them down. It was very difficult. And then somebody said, hey, what if we just make the wing tanks, what if we just make the fuel tank in wing shape? So all modern airplanes, the fuel tank, your wing is just a fuel tank in wing shape. This is
where I think he's getting too complex for no reason. Okay, basically the point is you're just using the battery as part of the structure. Okay, and they didn't used to. It's different with the wing because it's liquid, like he's saying, and not a solid material. So the solid material actually gives it structure more. But I get the comparison. But anyway, I'm going to skip forward to the actual difference because you got to see the battery difference.
It would be stiffer than that converter will be stiffer than a regular car. So it's just really
it's good for structure.
Really major. So it improves the mass efficiency of the battery, and then those castings are also quite important because you want to transfer load into the structural battery pack in a very smooth, continuous way, so you don't put arbitrary point loads into the battery.
Okay, now here's this is good. Okay, you can see on the side. Okay, there's actually more space between the vehicle, any vehicle impact, in the batteries. And this is what I was talking about earlier when it comes to the Cybertruck. One of my key concern with the Cybertruck, and when I did a Cybertruck video, is when that vehicle is going to be bouncing around and bumping into stuff, and it's going to be potentially rugged. Isn't that, this has to be structurally stronger. Okay? So, and I think that's what they've done here. They're making this structurally stronger, and there's more distance from impact to reach a battery for battery, damage. So I think that's a big part of it. And obviously, you have all this excess structure that you don't have to build. You have all these extra parts. So above is like the model, S or X or 3 or whatever, and then below is going to be kind of what the future of the Cybertruck or whatever.
You kind of have to, you want to sort of feather the load out from the front and rear into the structural battery. It also allows us to use to move the cells closer to the center of the car, because we don't have the in the top one we've got that sort of all the supports and stuff. So the volumetric efficiency of the structural pack is much better than a non-structural pack, and we actually bring the cells closer to the center, and because they're closer to the center, it reduces the probability of a side impact potentially contacting the cells, because it has to go, any kind of side impact has to go further in order to reach the cells. It also proves what's called the polar moment of inertia, which is that you can think of like when there's a ice skater, arms out or arms in. Arms in, you rotate faster. So if you can bring things closer to the center, you reduce the polar moment of inertia, and that means the car maneuvers better. It just feels better. You won't know why, but it just feels.
It handles better. Okay. The center of gravity, and he's explaining this kind of poorly for an engineer because he knows this inside and out, but I think he's kind of winging this here. But it definitely is going to make these cars more performance. All of the cars, they're going to be more performance. They're not going to feel like ass end heavy, or they're not going to be sliding around so much. They're going to be more centered. So the more weight to the center of the vehicle, the better inherently. Okay, instead of the outsides where you can have that weight continually trying to move out.
More agile. So it's really cool. This is really major. Like I said, so 10% mass reduction in the body of the car, 14% range increase, 370 fewer parts.
Wow. Now that's huge. 370, and here it is on the diagram. Okay. Current, there's the current Model 3, I guess, and this is the future of the battery. So many less parts. 30, and oh, there we go. There's another one. Less floor space. Okay, reduction in floor space, meaning again more area above the skateboard, more area for fun where they can do stuff with the cars. Okay, they have more area.
So
that's huge.
I mean, I really think that long term, any cars that do not take this architecture will not be competitive.
There and it's go. Not just warning, Ford, GM, other car manufacturers. If you do not take this manufacturing, you're done. You have got to do this. Okay, this is key. He basically gives them like breadcrumbs. Here's the breadcrumbs, and it's like nobody wants to follow the breadcrumbs. He's already done the work.
The product level, a better product, but in the factory, it's a massive simplification. You saw the part removal. It's casting machines. It's the structural battery pack. So we're looking at over 50% reduction in investment per gigawatt hour, 35% reduction in floor space, and we'll continue to improve that as we make the vehicle factory of the future.
Yeah, so major improvements on all fronts, from the cell all the way to the vehicle.
And in addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% dollar per kilowatt hour reduction at the battery pack level.
This is it right here. Okay. So you can see they break this down. They break it all down. It's very simple to see. Okay. And these numbers don't lie. I don't know if they're going to be precisely accurate. They'll probably get better at all of these. So they'll probably increase over time, percentages here and there, 14 to 15, 16, 17, whatever. So, I mean, 56 is just what I think they already know they can do now. I mean, they can get to that point. Okay. They can see that, and that's huge. 56% dollar. I mean, that's big. That's big. It's going to reduce the car. I mean, they can make the $25,000, $28,000 compact car that's electric.
Our total reductions now to 56% dollars per kilowatt hour.
Yeah. Yeah.
All right, so stacking it up, we're not just talking about cost or range. We've got to look at all the facets. So range increase, we're unlocking up to 54% increase in range for our vehicles and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler when we talk back about how do we achieve this scale problem here.
Yeah.
69, not a coincidence. He's such a goofball. It was probably like 68.2. He rounded higher.
Yeah, so I think it's pretty nice that investment per gigawatt hour reduction is 69%. I mean, who would have thought?
Yeah, just happened to happen out that way. Okay.
I mean, 0.420%, of course.
Yeah, and this is the chart I was talking about.
Yeah, so what this enables us to do is achieve a new trajectory in the reduction of cell cost. And now, to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years or thereabouts. So
a year to 18 months. Okay, is that what he's saying for the Cybertruck? A year to 18 months. So a year from now is obviously next September, October, November, December. So yeah, I think if he's accurate about this, and even if you go to the 18 months, that means it's definitely like the Cybertruck could be pushed back to March, maybe April, even of 2022. So that's a possibility. But I mean, if he's talking about a year, meaning everything goes perfect for them, then it's a year. You're talking about the first deliveries of the Cybertruck next October 1st, maybe. That would be the earliest, and then the latest would be probably in April, May, June of 2022. So I think that's another reason the stock kind of had a sour reaction of this, because I mean, they probably wanted to hear, oh my gosh, the Cybertruck is ready to roll. It's like not battery wise. So
it
get into the Q&A too much. I'm just going to summarize a few points. They were talking about potentially a pet project doing the HVAC for homes and stuff. I can see them manufacturing all kinds of things like that in the future. Eli Burton from My Tesla Adventure, he was talking about the dream case or something in the with is the Cybertruck going to have air conditioning in the back? And Elon wasn't really thinking about it, and I guess they hadn't talked about it. He's like, yeah, that's a good idea, but and let's see. And they were somebody was asking about, well, what's the future of the ICE vehicles and everything, and he's basically like, there is no long-term future. They're not going to exist. So again, do you believe him? Do you think he's crazy, or do you think ICE cars are going away? I think they're going away. It's a question of when, not if. Okay. And Ryan McCaffrey from Ride the Lightning, he asked a question about it too. And let's see. They were talking about the production of the Cybertruck, and he said they had over 500,000. He said he's 600. He's like, we stopped counting. So I'm not sure, how many actually. I was thinking they had about 1 million, but now I'm not sure. Maybe they only have 500,000 or 600,000. I'm not too sure about that. Ross Gerber also asked a question basically about climate. That is this, the opportunity for to work at Tesla and everything, but basically to change, the climate situation we're in, and he's from Gerber Kawasaki Investments. And let's see, somebody asked about, basically that it's lowering the cost of sustainable future. So it's actually going to be a cheaper sustainable future. It's not going to cost more money in the future to be sustainable. It's actually going to be cheaper than where we're at now. That's the real big advantage long term there. And Galley also asked a question, and they were like looking around for him and everything. So that was kind of funny. And he was talking again. Galley basically he wants a plane. He definitely wants a VTOL jet, but I don't know exactly. I mean, it was kind of sloppy about what was going on there. But anyway, let's see. Oh, and selling the batteries to but basically, Elon's basically like, yeah, as far as I don't know exactly what he was saying about it. I'm kind of paraphrasing, but they don't have a surplus yet. I mean, essentially, when they have a surplus of batteries, then they can sell batteries to everybody else. But they have a lot of projects that need batteries, so they won't be selling batteries for a while, as far as that goes. So let's see. And he's basically saying, hey, we've got the recipe. Here's the recipe for everything. You know what I mean? This is really the recipe for all the other companies. All they have to do is follow it, to make their cake or whatever, and that's me paraphrasing it essentially, you know. So, and he's basically ploying to miners and engineers. Again, he's always recruiting. So he's recruiting for miners to do their thing and mine more nickel, and also just for engineers to come work for Tesla. I don't even think he's asking for engineers to work for SpaceX. He's just saying, come work for Tesla. We need you at Tesla. They probably don't even need people at SpaceX. They're not trying to crank out 100,000 rockets, okay, per quarter. So anyway, so that's basically, I just wanted to go over that. And he basically, all of the investors on say.com, he basically went through it. He's like, okay, we answered this, we answered this, we answered this. And he kind of blew it all off. I'm pretty sure he's not a big fan of the institutional investors and their questions because they're either kind of redundant or, I don't know, sometimes ridiculous, I guess. I don't know. But I mean, that he's not too friendly to that scenario. He just kind of, hey, can we scroll down through this? So, but anyway, that pretty much sums it up. I hope this video didn't drag too long. I just wanted to really cover this in detail and give you my opinion on where we're going battery-wise. And this is why I'm leaving this on the cell design, cell factory, material, and anode materials, cathode materials, and the cell vehicle integration. So they're working not just on one thing. Let's just make a battery better. Okay, they're working on every process. Now ask yourself this, and this is what I think about, are the other companies building electric cars working on these processes? Any of them? Yeah, crickets, as in no. Maybe cell vehicle integration? Maybe even cell design potentially. But I'm pretty sure they're not doing anything with cell factory anode or cathode materials. I'm pretty sure they're not doing any of this stuff. I mean, I'd love to see something about it, but Tesla's constantly on the tech edge of this. So, to me, this is big moving forward. Again, this is big moving forward. I'm pretty sure the investors are going to be like, who cares? This is going to take years to materialize. Institutional investors, for the most part, think quarter by quarter, what's going on. They're not looking 2, 3, 4 years ahead. Okay, that doesn't interest them. Okay, they're making bets, week to week, month to month, quarter to quarter, maybe year to year, but not usually looking that far down the road. So anyway, I'm going to wrap it up. I hope you guys found this kind of interesting. I tried to break it down as much as I could. I know this video went long, but I definitely wanted to talk about it, and I'll be posting another video probably tomorrow, surprise video. So anyway, maybe you want to check it out. Anyway, have a great morning. It's 4:30 a.m. Working hard for you guys. Hope you guys liked the video. Take care.